You've seen already that the graphs of sine and cosine are pretty similar. We basically do them the same way. They have the same shape. The only difference is that the graph of sine starts at the midline and the graph of cosine starts at one of the amplitude lines. But the graph of tangent is different. It's just a different shape. And to be clear, what we mean is a graph of something like y equals tangent of theta. So let's take a moment just to kind of figure out what this shape is. I've got a portion of a unit circle. I've got a full circle. I only marked out certain points on it. And for reasons that I'll show you in a few moments, I've actually started with negative pi over 2. So I've started down here. And then I'm basically doing all of the 90 degree or pi over 2 spots. And I'm doing all of the sort of 45 degree pi over 4 type spots. And so let's figure out the tangent of all these angles, and then we can kind of put that together and see what the graph looks like. And just as a reminder, we know that tangent is sine over cosine. It's also opposite over adjacent, but that's the same as saying sine over cosine. And that when we're looking at a unit circle, tangent is y over x. So let's figure out tangent, the value of tangent for all these angles. And there aren't going to be that many different numbers. So we'll start down here. Here's negative pi over 2. Y over x is negative 1 over 0. A number over 0 is undefined. So we'll just start with that. At negative pi over 4, y over x, they're the same number. There's just a negative sign there. So the number parts cancel out and just leave us with a negative sign or a negative 1. At an angle of 0, y over x is 0 over 1. That's 0. At pi over 4, they're the same number. They cancel out, leaving us 1. At pi over 2, 1 over 0 is undefined. So let's see if this starts a pattern here. 3 pi over 4, same number, so they cancel out. It just leaves a negative sign, so negative 1. At pi, 0 over negative 1 is 0. 5 pi over 4, same number, they cancel out. The negative signs cancel out. Everything cancels out, leaving us with 1. And at 3 pi over 2, negative 1 over 0 is undefined. Sure looks like a pattern, doesn't it? And we know that these trig functions all have patterns that go with them. So let's do the last two here. 7 pi over 4 is the same as negative pi over 4. So that's negative 1. And 2 pi is the same angle as 0. So that leaves us with 0. So clearly there is a pattern. Let's put these points in and see what this actually looks like in terms of a graph. And we'll start with these undefined points, because when we have points that are undefined, that indicates that there's an asymptote there. And so I'll put an asymptote in at negative pi over 2, at pi over 2, and 3 pi over 2. Okay, and those are, yeah, that's close enough. And let me also mark here that we have, we'll say that that's 1 and that's negative 1. Okay, so here's negative pi over 2, and then here's 0. So that's negative pi over 4 would be at negative 1. 0 is 0. Pi over 4 is positive 1. And our asymptote. And then this pattern repeats. So we have negative 1. So this would be 3 pi over 4. And then at pi, it's 0, positive 1. And then asymptote, negative 1, 2 pi, we get 0. And so you can see that this pattern would repeat. So what does the actual graph look like? Well, it's not a straight line, because we've got these asymptotes here. So what it is it kind of starts down there. It sort of looks like a cubic graph. Starts along the asymptote, curves in, and then curves up towards the asymptote again. And so the graph of tangent is, we could keep going here if we want. The graph of tangent is different from sine and cosine graphs in a couple of ways. First is that it's in pieces. It's not like one continuous curve. It comes in pieces with asymptotes in between them. The other is, if we look here, like how long does it take to make a complete cycle? And we'll look at the graph too. So from negative pi over 2 to positive pi over 2, it goes through a complete cycle. from there to there is only pi, right? And then from pi over 2 to 3 pi over 2, it goes through another complete cycle. That distance is just pi. And we can see that on the graph as well. So there's the first cycle that takes pi units to happen. Here's the second cycle that takes pi units to happen. What we're getting at is, you'll recall that the period of a sine or cosine graph was 2 pi. But for tangent, that's not the case. It only takes pi units to go through a complete cycle. So for tangent, the period is just pi. So let's get into how to actually graph one of these. Now that we know the general shape and we know that the period is pi. So here we'll just graph y equals tangent of theta, and I'll take you through the steps for graphing a tangent function in general. It starts the same way that we started with sine and cosine, which is finding the period. In this case, because the period of tangent is pi instead of 2 pi, it's not 2 pi over b, the period is just pi over b. This is for tangent only. Okay, so in this case, b is just 1. This is like 1 theta. So the period here is just pi. This is just a standard tangent graph. We're also going to find segments, just like we did on sine and cosine graph. And just like sine and cosine graphs, it's going to be 1/4 of the period. So here the segment is going to be pi over 4. And again, this is just going to help us to graph. Here's one way that doing tangent graphs is really different. When we did sine and cosine graphs, we'd say like, here's our starting point, and then I'll go 1, 2, 3, 4 segments this way. And that would be a complete cycle, right? When we're drawing tangent graphs, we're going to say, here's our starting point, and we're going to go 2 segments to the left and 2 segments to the right. Here's why we do that. Our starting point, if we look back at this graph, here's our starting point at 0, right? Do you notice how that's actually in the middle of one of these chunks of the tangent graph? We don't actually want to start there. We want to start here and end there. And in order to do that, that means we have to start our graph 1, 2 segments to the left and end it 1, 2 segments to the right. And that's where we'll find the asymptotes. So getting back to this graph, our segment is pi over 4. So we're going to go from our starting point at 0, we're going to go, so there's pi over 4, 1 segment to the left, oops, 1 segment to the left, 2 segments to the left would be negative pi over 2. And then 1 segment to the right, 2 segments to the right would be positive pi over 2. And that's where we're going to draw our asymptotes. So I'll put those in. So that's always how we start drawing tangent graphs, is going 2 segments left and 2 segments right and putting our asymptotes in those places. Okay. And so now we're ready to put in some of the other points. Our starting point for tangent is at 0. So let's go back and put in at our starting point. Well, I've kind of have it in already, but here in the middle, it's at 0. And then our pi over 4 points, we're at -1 and +1. And so that's what we'll put in here. These are, and I should label, pardon me. Let me put in, we'll put in that's -1 and that's +1. Okay, so we'll put in at negative pi over 4, negative pi over 4, we're at -1, positive pi over 4, we're at +1. And now, guided by the asymptotes in those 3 points, we can graph. So we'll start at the asymptote, curve up, and then curve again along the second asymptote. And if we wanted, we could do another cycle of this. So we'd have 1 more segment, 2, 3, 4. We could put in another asymptote right there and kind of have the same point. So the middle, it's at 0. This point's at -1. This point's at +1. And now we can connect them in the shape that we know. Good. All right. So that's how we graph a basic y equals tangent of theta graph. Let's do a couple where we have some transformations. And there is a typo in this, so let me change that. I say typo as if I typed it, whatever it's called, a righto. Okay, y equals 1/2 tangent of 2 theta. So we'll follow the same process that we talked about on the last one. There's just going to be some adjustments here. For tangent, the period is pi over b. In this case, b is 2. So we've got our period is pi over 2. Next, let's find our segments. So each segment is going to be a fourth of that. So we can just write it like that if we want to. So that would be pi over 8 for each segment. So we can do some labeling here. We'll go from our starting point. We'll go 2 segments to the left. So that would be -2 pi over 8, which is -pi over 4. And then same thing in the positive direction over here. Okay. So let's look at what this number does. It's the amplitude, just like it was when we had, let's say, y equals 3 sine of x, or 3 sine of theta, I should say. So this means that the amplitude lines were up 3 and down 3 instead of the regular up 1 and down 1. And it's basically going to do the same thing here. If we look back at these points, here we said these points are up 1, down 1. We did the same thing on this graph. We went up 1, down 1. And so now that the amplitude isn't 1 anymore, it's 1/2. That means those points are going to be up 1/2 and down 1/2. Okay, so I guess first let me put in my asymptotes. So I'll put in one at pi over 4. Oop, I put the wrong thing in there. No, that's fine. And one at -pi over 4. So I've got my asymptotes. And now I'm going to label that the amplitude, so I'll do it right there, is up 1/2 and down 1/2, so -1/2. I've got the asymptotes. I'll put in at this, so our starting point, it'll be at 0. Here it'll be down 1/2. Here it'll be up 1/2. And then I can draw the shape that we know. Helps to leave yourself a little bit of room to get that curve. I put this point a little too far down, so I made it hard to really get that curve. But you recognize the general shape I'm trying to do there. And again, we could do another cycle. A lot of these will probably ask you for 2 cycles. And if we needed to do that, then we would just keep going over 4 segments at a time. So I put 1, 2, 3, 4 more segments. We'd have an asymptote here, and then we'd copy these same points in between. So let's do one more. And I, again, for some reason, wrote pi, which is not what I meant to write. I meant to write theta. Okay. Period is always, for tangent, is always pi over b. In this case, b is 6. So our period is pi over 6. To find our segment, we'll multiply by 1/4. And so our period is pi over 24. This does not mean you need to make the graph very tiny. Just adjust the graph to whatever the segment, whatever the period are. I'm going to move this over just to make my general graphing easier. So I'm going to make each pi over 24 nice and big. I'm going to do, there's -pi over 24. And then 2 pi over 24 would be pi over 12. And I'll do the same thing in the other direction. Positive pi over 12. Positive pi over 24. Nope, that's backwards. There we go. Pi over 24. Pi over 12. Okay. And I'll do asymptotes at those points. As we know, 2 segments left and 2 segments right. That's where asymptotes go. And then our amplitude is 3. So I'll mark this as 3 and -3. Then there's one more thing we need to account for, which is this negative sign. And just like we've seen with other graphs before, that negative sign is going to sort of flip it upside down. So whereas previously we've been like low left and high right, now we're going to be high left and low right. And we have our usual point at 0. And so our graph now is going to start up by this asymptote, curve down like that, and then curve down towards the second asymptote. And we can throw in one more cycle here. So we'll go 1, 2, 3, 4, close enough. Put in an asymptote there. And we'll copy over those same points. So we've got there, center, down, same shape. Down. And then we'll just make sure that we get the, sorry about those sirens, if you can hear those. Then we'll just make sure that we get, okay, so this was pi over 24, 2 pi over 24, 3 pi over 24. 3 over 24 is 1 over 8. So that would be pi over 8. 4 pi over 24 is pi over 6. 5 pi over 24 doesn't get reduced. 6 pi over 24 here is pi over 4. And that would be our two cycles of our graph here. So a little different than graphing sine and cosine. Main things are, first, understand the general shape. Second, know that the period is pi, not 2 pi. Third, and this is probably the biggest thing for graphing, is to understand that from the starting point, it's not like 4 segments to the right, that you have to graph this by starting 2 segments to the left, 2 segments to the right, and that's going to be one chunk of your tangent graph. And then, and then amplitude determines how high these sort of middle points are. And this number determines the period of your graph, just like it did with sine and cosine.